Hello and welcome back to another festive coding session with Mr. Jacob. Today we want to tackle another of our Advent of languages, where we implement in the 24 first days of December every day the same thing in another language. And what we are implementing is more or less the output of something like this Christmas tree, either in a graphical way if we are in a particularly graphical language like, for example, Logo, which we already had, or in an ASCII art way when we are in a language which can easily print out to std out. And today's language of choice is actually Erlang, and we will implement this in Erlang. Erlang is actually a virtual machine environment which was initially developed by telecommunications networks. I guess it may have been AT&T, I'm not 100% sure, to actually control in a heavily parallelized and concurrent situation their phone switching thingies there and their infrastructure. And it was needed to be highly fault tolerant and very, very concurrent, so that actually this thing came out of it. And if I remember correctly, the server version or the server the server basis of WhatsApp, for example, is written in Erlang as well. I'm not sure if it still is, but if I remember correctly, it was. And as you can see, Erlang is kind of a language for this heavily concurrent processing. So it's essentially a really good fit for today's web situation there, web scale applications. However, it is not used a lot of the times. We will take a look at this now and we will execute or create our Christmas tree with it. Erlang actually is a very functional language as well. And the only thing that I have prepared here, as so many times before, is the build environment. And as I don't have that on my machine here, and the Erlang VM can be a little bit troublesome to install, I have simply wrapped all of this stuff within a Docker container here, and the run target will actually compile the code into the VM bytecode and then call up within our tree module, which we will write in a second, the draw function. So this, so to speak, will be our entry point. So let's go ahead and create our tree Erl function here, which should start with some sort of module declaration to tell the system or the VM that we are now creating the module tree. We will call that tree. And now we need to export our entry point here, this draw function that you have seen in a second before, by calling this specific export command here and telling it that we are exporting a list. Those square brackets are a list in Erlang of the following things. We are exporting the function draw with an arity of 0, so to speak. So it does not have any arguments, so it has an arity of 0. Different functions can exist in Erlang with the same name but different arity, which is quite a neat thing. They will be identified and handled in an unique way, so it will be able to identify which of those functions you have called. So you can actually easily create functions with the same name and a different arity. That's why we need to specify that here. And statements in Erlang actually always end with a dot, which I have forgotten to print here, and I need to print that there. And now we actually kind of have already our minimal Erlang module. We should, of course, define our draw function maybe, and we simply do that by specifying the draw call here. We can do pattern matching here, which we will see in a second. And then we simply tell Erlang what this function should return. And in our case, we will use something that is not really functional at this position. We will do an IO format. It is handled in a functional way. However, we will return an IO format, which in turn actually can print out stuff like, for example, we can use a kind of printf syntax style. It is not printf syntax, it is a completely Erlang based syntax, but we have those placeholders here. So we can do something like, for example, ~p, ~n will do pretty print me an Erlang term that I give you, and print that out, and a new line at the end. Or, for example, a string. We can start with a string, for example, and then we give it a list of all the different replacements that we want to insert there. And in our situation, this would maybe just be hello Xmas for a start here, and a dot to end this function. So let's kind of see if this works already, if I've done everything right with my make file. So if I do make run now, it should actually compile that and run that. And as you can see, we have hello Xmas. So we have already seen that we have a way to output something to stdout, which is perfect for our Christmas tree. And we have our basic file definition here and our entry point, which is simply called draw here in our case. Okay, perfect. So that we now have that, let me quickly get our example tree thingy here over from our initial README file, because that's always a neat thing to have in our code to just see, wait a second, what? To just see, I did somehow not grab that into the right register, I guess. So let's put that there. Yes, perfect. And let's remove the spaces and let's quickly add comment signs, which are a percent sign in Erlang, so that we now have a neat little Christmas tree here to look at while we are creating the code to draw it. And as I've said already, Erlang is a quite heavily functional language, which we will see in a second. Because the first thing that we need to do is we need to somehow draw those groups here, those two and those two lines and those two. So essentially those combined variants of those slash and backslash characters, which are grouped always by two lines and create those zigzag shapes of our tree. So how could we do that? We could, for example, call a function here called draw groups. Let's call it draw groups. Come on. And we give it the amount of groups. And we've further defined that we want 7 groups, for example, so that we can actually do that. And yeah, I guess we can remove that. And then there is some sort of Erlang convention, which says that functions which finished successfully mostly should return an atomic, which is called OK. So you can have arbitrary atomics in Erlang, which are very efficiently generated and used by the VM, which is quite a nice thing. So you can actually have some sort of atomic state placeholders there where you can identify tuples with, for example, or other data. That's actually more or less used to identify data types. So I could do something like, I could create a tuple here, something like my data, and then I would put some data, for example, the groups here, or I could do something like groups, and this would then return a tuple of this atomic groups with the value of groups behind that. And then I could pattern match that to ensure that this type is kind of transferred there. This is more or less how you create your own types in Erlang most of the time. Not always, but most of the time. However, we are simply returning the OK atomic here, which does nothing further there. Now we need to define our draw groups thingy here, which should be taking our groups here, and it should do something with that. And what should it do with it? It should essentially now iterate through our groups, because we need to somehow iterate. We want to draw each of our groups. However, there is no easy way of iteration in Erlang. There is something like list comprehension, as we have seen with Haskell before. I will link the video up in the top right corner there, which we have seen in our Advent of Languages before. However, what you mostly use in Erlang actually to create loops is recursion. Erlang can very efficiently do recursion calling without the usual problems of that you have when you call something in a recursive manner over and over and over again, like your stack will explode. That's not the problem with Erlang actually. So we can do this using recursion and simply doing something like we might implement another variant of our draw groups thing in a second, where we implement something like we give it one parameter where to start, or where we are currently at, so our iterator, and our end, which would be groups. So we are just kind of kicking off those operations here. This would be one draw group thing. That actually would then be draw groups with an arity of 1, as we have seen before. And now we do draw groups, and we give it an n, for example, and a groups. Now this function has an arity of 2. So we can implement that as well. So let's quickly see how we could do that. We could, for example, now simply implement our draw groups thing here. Let's, for now, just do something like, just to see if this works properly. We could use our IO format here, and we can use something like our P here, which can be used to pretty print any kind of Erlang term, and a new line, yes. And we then specify in a list, for example, our N. And then the next thing that we will do is we will call draw groups again, and we will do n plus 1 and give it the groups again. And this would be the end of this draw groups. Now, however, you might ask yourself, okay, this will never stop. You have just created an endless recursion. And you are right, I have just done that. So we will simply implement another version of this function here, which takes kind of another pattern matching type here, or which is pattern matched against something else. That's why I'm doing a semicolon here and not a dot to end this term. So we simply now say we have another pattern matching block here, which checks if those two are actually the same, because if those two are actually the same, then we can actually stop because we are at the end of our iteration. However, this, of course, here will always match. So I just can't do that here because this will always match before that. And therefore, it is quite essential that I do some sort of condition here, which I can do. I can tell this, okay, pattern match that, but check that n is less than groups. So in this case now, I can make sure that this will match only for every case where those two are identical and where this is actually not matching. So this should actually work. We will see in a second. So if I now do make run here, it should actually give us the numbers 1 to 6. We specified we would like to have 7 groups, so it did exactly that. It recursively called this thing here, this expression here all over again, and iterated through all of our groups. That's kind of perfect. So let's start drawing out our real groups. And we can actually, or we need to kind of create spaces for that, don't we? So we need spaces that are this correct amount here, then we need those inner spaces here, and we need those characters there between those. And we can actually use something there from our string module. There is actually a string module in Erlang, and we can call something from a different module like we did with the IO by simply providing a colon there and then using that thing. And there is chars, and chars actually can give us a repetition of a certain character, and it gives us the amount of times that we want it, and that is a string. Essentially, in Erlang, a string is only a byte sequence. So Erlang doesn't know about Unicode or any stuff like that. It simply has strings as byte sequences, or better said, as lists, because a string is a list of characters. And a character, as far as I remember in Erlang, don't quote me on that, is a byte. I'm not 100% sure. There might be something special with characters. However, this essentially only is a list that is returned by this function. So what we can do is we tell it that we want the literal character space here, which essentially we are telling the system that we want a literal character somewhere. We are starting it with a $, that is Erlang syntax, and then a space, which might not be the best way to read this. We could, of course, do something like ASCII character 32, which should be space. So we can decide between those two syntaxes. Maybe we will do 32 here. I'm not sure. Let's do it like this, and then we simply specify how many we want. So how many we want here is we want groups minus n, because that's the amount of spaces that we need in front of those lines here. So now we actually have those. So let's call those maybe outer spaces. We can simply put them into a variable here, and let's do the same thing for inner spaces. So string chars, and we want the literal space character here, and the inner spaces actually are n times 2. So no, yeah, n times 2. We want n times 2 inner spaces. So that is not something that we have. And now we could actually print that. So we could do something like print a string this. However, we of course need to put all of that together, and that's actually quite easy because, as I've said, exactly as in Haskell, all those things are just lists of each other. So we have a list of bytes as a string, so we can concatenate them, and we have a larger string. So we simply do string concatenation. So what we can do actually is here we can call this line 1, for example, because all of those groups always consists of 2 lines, like this one, and we are now creating line 1, which we want to print out. So let's create that by simply doing something like outer spaces plus plus, then a string containing this slash, then we want to concatenate inner spaces, and then we want to concatenate this one there. And now we should actually have our line 1 string here, which we now should be able to print out. So let's see if this actually works and gives us kind of half a tree. And as we can see, it does not. Most likely because I've forgotten a comma somewhere. Yeah, there I've forgotten a comma at the end, and there I've forgotten a comma as well to indicate that there should be the next statement. And as you can see, we have already one line of our 2-line thingies here. Now we could think about, wait, what did I do? I somehow opened up the NeoVim help. I didn't want to do that. Now we could take this here and put that there and try and do that again with the different values. For example, like we need groups, we need one less space in the line below, because as you can see, the next line always, the second line always has one space to the left less, and we need n plus 1 times 2 spaces in between, and we could create line 2 here. And then we would simply print out it like that. What do you think? Does this work? No, it does not. It does not, because we have actually a bad match. That is nothing that I would have actually expected here. The reason why I think we can't do that is actually because you can't redefine variables in a function. So this should actually be outer spaces 1, 1, 2, 2. And so this should be 2, 2, and this should be 1, 1. So let's see if this now works. And as you can see, it does. So the error message was a little bit strange there. If we would have read into that a little bit more, we might have detected what is wrong there. That's actually kind of a little bit of a problem with Erlang. You need to really work with that to be able to read those kind of cryptic internally created error object thingies there, which are usually only tuples and lists put into each other. Okay, now that we have actually drawn the groups, or at least, yeah, that we have drawn the groups, we can go ahead and add something else to our draw function. We can now do something like draw divider. And it needs the number of groups, of course, as well. So let's define a draw divider function here. Draw divider. And it takes the groups, and it will simply do, yeah, the same thing, more or less. It will take the divider here, and it will do string chars, and this time it will do the literal character minus, and it will do that groups times 2 plus 2, because that's the amount of dividers that we need, and we will do IO format. Yeah, let's just kind of, because it's hard for me to type that on my keyboard, let's kind of steal that there, and let's just put in there, no, not some type stamp, it wasn't even the current time. Divider, And this should actually now give us the divider. And let's maybe just go ahead directly and do the trunk as well. So let's get the trunk here and let's define draw trunk. And it takes the groups as well. And we could do something like why divider? No, we will do trunk, and trunk will be string chars. And what we want here again is spaces, and we need groups times spaces. And we want to concatenate that with a string, which is two of those nice little thingies here. And now we should be able to do IO format, and IO format should be $S, $N there again, and the trunk followed by the trunk. However, we want that two times, so we simply concatenate both of them into one element here, which will not work, I guess, because we need some sort of, can we actually, I'm not sure if this actually works. Most likely then I would need to do something like that. Maybe this works. I'm not 100% sure. Let's check if this works actually. So we will see in a second, I guess. So syntax error before IO. I guess I have somewhere, yeah, I've not done a comma there, and this needs to be a dot. And we should do maybe something like OK here. And we should do something like put a comma there as well, and a comma there as well, and return OK here as well, just to be good, neat little Erlang citizens there. And let's do a run. And syntax error before OK. So I guess there's a comma missing. And now let's see, what did we do wrong now? We did something wrong with the trunk creation there, and I guess that it is this thing here. However, I'm not sure if this is possible. Let's see. Okay, this kind of works out. So as you can see now, we have our Christmas tree printed out in Erlang. However, I'm just thinking that it is a functional language, so I think we should kind of get all of those string parts together, actually without always using the IO format. So using the side effect that is called there to kind of get that. So I think what I want to do is down to here, I want to replace everything that is called draw with something with maybe make or something like that, because I want to rename all those functions to make groups, make divider, make trunk, and stuff like that. And then only our initial draw function should maybe print out something. And I think we can do that, like we can say tree, and we then do something like we do the draw groups, and we concatenate that with the make divider, and we concatenate that with make trunk, and then we do an IO format, which is then in turn taking this as a string and maybe putting a new line at the end and then putting that out there. And all of those things here actually now return stuff, which in turn means that the make groups, of course, need another a third input there to actually transport the already generated output through their context here. So what we will do here is we will simply put in an empty list for a start, and we will now go ahead and tell this system that this is the, maybe we call that lines. And we will of course need something like when this one ends here with lines, then it is okay. And now we need to generate all of those lines. We already generated them. We need, of course, to add a new line at the end of all of those lines. We before used the IO format for that, so we can now remove that. And we need to add a new line here as well, so that we have a new line there at the end as well. However, No, I'm not sure. We don't need this new line. I guess we will add it in the end when we combine all our lines together, because we are generating a list here. And maybe we should generate a list of lines from each of our functions. That's actually a more neat way. So what we can do here now is, um, we take those two thingies here, and we take our already created lines here, and we concatenate that with uh, um, a new list, which has now the two lines in there, so that in the end our given lines here into the recursion has two more lines, and our make groups in the end here will not return okay, but it will return the lines, because now we have a return value here that we want to return. And therefore this one will simply return that, and we have the lines there now, and we can actually, we will need to change something here to introduce the new lines in the end. We will see how we actually do that. Okay, so now let's see, how do we do that with a divider? We generate this divider. So we now have our divider line here, and in the end we simply can, I guess, return then a list of lines. So it is only one, so we only return one divider here, and the trunk will be more or less the same. We remove that, we remove this new line here, and we then simply return two times the trunk as a list there. So now the only thing that we need to do in order to print this properly, let's see what happens when we do that. Everything should be actually on one line, which is of course a problem. Let's see. Okay, no, we did something wrong there. So what did we actually do wrong there? Wait a second, come on there. Warning, the result of evaluating or operator ++2 is ignored. Suppress the warning by assigning the expression to, okay, tree and so on and so on. And yeah, why is that? The requires an argument list with one argument, but no argument is okay, guys. I see the problem. I have never used that actually, so it kind of removed this during compilation. However, we can't treat this as a string yet, because it still is a list. So let's see what actually Erlang does of it. It gives us this list here, which contains all of our strings, which is quite nice. You can see that this actually kind of worked out, but we now need to more or less print them with new lines in between. The easiest way to actually achieve that in Erlang would be using a list comprehension, I think. So what we essentially want to do is we want to call this IO format thingy here for each of our list entries. So how we can actually do that is we kind of tell Erlang to create a new list, but we don't really care about the list. However, we can do that using list comprehension, which makes a new list of some term that you give it, plus something that is already a list and can be kind of used to create that. We will see in a second how this actually works out. So what I do here now is I do something like IO format, or I could actually use that. So let me quickly do that. We create a new list. That's why we are starting the list syntax here. Then we are telling it that we want to print a string, and this would be something like we want to print line. However, we don't have line here, so we are using the list comprehension syntax, which simply tells the system that we want to iterate over another list, and we want to for each of those list elements should be matched against what I just wrote here. We want to simply extract the element, the string. So I'm simply matching against one argument here, and I'm telling the system that I want to match against our, we called it tree, I guess. And our tree consists of lines. So this is essentially an arbitrary list. And for each of the list items will be matched against this one. And for each of the matches, a new item in our list comprehended version here, and our new list will be created, which actually will, of course, be created by calling this. So we are outputting then the string. And in the end, we are creating a new list, but we don't care about that list. So let's do that, and we should have our Christmas tree. And there it is. List comprehension actually is a very and really neat thing, which is often used in functional programming languages. We used it in Haskell as well. However, this is actually the one way to do this in Erlang, and I hope you liked doing that. I hope you learned something, like, for example, the way of doing using recursion in Erlang for iteration and transporting information. That is actually really common in Erlang, that you transport iteration through cycles. For example, if you implement something like a request handler, or something like some server which has a state and can execute different commands asynchronously, then you are usually transporting the whole state of your system, which is needed in this case, by simply invoking the function which waits for the next request to happen in the end with the updated state, for example, and simply invoke that again and do that recursively, because Erlang is just really good at that stuff. And therefore, using that to transport data and state in your application, you are often using that to transport data like that. Yeah, as I've said, I hope you enjoyed this. I hope you learned something, and maybe you will play around a little bit with Erlang. And I hope you will join me in the next iteration of the Advent of Languages tomorrow, when it is the next day, and we will go there and implement the next thing. Thank you and goodbye. See you in the next one.